going on, guys? Yo, how is it going? What's up? What's up, guys? What's up, Jacob, Peter, technical specialist, Stephen? What's up, guys? How's it going? Hope you're doing well today. It is a Friday, I think, today. Yep, it is a Friday today. Loving life. Nice early Friday stream. Cargo, what's up, buddy? Gonna take a look at this little B2 audio first, I think. This is a little B2 audio Riot, Rage 600.4. It's one of the older ones because it has the older B2 logo. You know what's funny about how our brain works? So you see how the B2 logo here, it clearly says B2. However, it doesn't actually say B2. Like this line, this is just a black line that changes in width, but your brain sees it as a 2. Like, just look at that line as a line. That's not actually a 2, but it's forming the black border for what would be a white 2 on a white background. So although none of these lines resemble the shape of a B in any way, shape or form, your brain's like, oh, it says B2. It's pretty cool. We're able to get a DATS on lens. So basically, yeah, a few people very kindly reached out and offered a DATS V3. So I've got one on the way from a very kind guy in the UK who's lending me his for the time being until I can get my V2 fixed. And there's another guy in the States, I think, that wanted to just send me a V3 anyway. So I guess I might end up with a V3 anyway, which is amazing. So yeah, the community response to my stuff crapping out has actually been overwhelming. I'm eternally grateful for everyone's support on that side of things. I didn't expect that at all. Just kind of wanted to let you guys know that there'd be a small delay on the videos, but yeah, so many people reached out offering to help out with either a V3 that they had, or someone they knew or something. So yeah, it's really cool. Okay, cool. So this is a B2 Rage 600.4. This is a Class D amplifier. This is using a IRS 2093M 4-channel Class D driver. Let's check this. So yeah, this little drive IC here is a little 4-channel Class D drive IC, and that is running some Mosfets on the output side. Now these are dual Mosfets, so they're 2 Mosfets in the same TO220 package with 5 legs. So basically they are 2 N-channel FETs, and you're able to use one of them as a low side, one of them as a high side. They're specifically designed in that way. They have a common one of the FETs drain is connected to the other FET's source. So there's common drain source between the 2 FETs, which is perfect for Class D bootstrap operation. So that's really cool to see. Means you can just have one TO220 package for two Mosfets inside. So what is wrong with this little thing then? First of all, let's have a look and see whether any of these FETs are shorted out inside. That one seems alright. So we've got 4 because we've got 4 channels. Okay, seems alright. Okay, so the FETs don't seem shorted. I think I know what this is going to be already, but we'll find out shortly. Let's plug some power in and see what we've got on the output side. Have you ever worked on a kicker at 2500.1? Yes, I have, Stephen. Right, shove the remote in there, shall we? Get in there. What's stopping you from going in? I'm actually not a fan of these terminals where the grub screws are at a 45-degree angle. It drives me kind of nuts. I know that it's technically better because it prevents the wire from pulling out, but it's just a bit of a headache to get them in the first place, and yeah. But I do understand it. I think if I was designing an amplifier, I'd probably have, if I was having these terminals, I'd probably use these as well that are on an angle here, because it does just pinch the wire much more securely in place, and makes it very, very difficult for you to accidentally pull the cable out. You ever going to expand into repairing PA amplifiers? Yes, I am. I have a few PA amplifiers sitting around that I am just waiting to get started on. So yeah, at some point soon we'll be doing some live streams trying to repair some PA amplifiers. Stephen says on the kicker, it's interesting how they use 3 N-channel FETs and 5 P-channel FETs. That's because the P-channel FETs are way less powerful than the N-channels. So it would actually be more weird to have the same number of P and N, because then you'd have an imbalance of the current carrying capabilities and the RDS of the N bank versus the P bank. So by having only 3 versus 5, it's now balanced current share and also saves cost. Okay. Why is this in the workshop? Let's power it up and see if we got output switching on any of these little dual output FETs. Let's probe the inductor here, the input to this inductor, because that will tell us whether there's Class D switching or not. Okay, no Class D switching, just a little bump up there. So we've got no switching on that one. No switching there either. Okay, so in my experience with these, the most common problem seems to be that this IRS 2095, what is it, sorry, let me start that again. This IR 2093M, this IC, it runs pretty hot, okay? That's not a problem in itself, but the constant heat and cooling cycles that this chip goes through in normal operation causes the very, very, very tiny solder connections on the pads here to actually crack and become desoldered a little bit. And that's because, you know, in a vehicle environment, this amplifier might be sitting overnight at, you know, -1, -2 degrees centigrade. In the morning, it's up at like maybe 3 or 4, and then you turn the amplifier on, and within a couple of minutes the chip is now running at like 60, 65 degrees centigrade. So it's going through pretty intense heat and cool cycles on a regular basis. And that does cause, the constant expansion and contraction of the solder does cause cracks to form, and I think that this probably just needs the chip reflowing. So I'm going to drop some fresh flux on this IC here, and just give this a little reflow, and I suspect that's all it will need, but we'll find out soon enough, I'm sure. Yeah, basically the same issue as the old games consoles. The Xbox 360 was renowned for that. So these boards have a reasonable amount of thermal mass. It's not crazy high, but I'm just going, they do have a tendency to popcorn, to blister the PCB. So I'm just going to heat up the area around this chip for a while first to get some heat soaked into the board, so there's less of a temperature difference between the area that I'm heating and this chip. Peter says my B2 Audio 6 channel that did that times 2 and you repaired it. When it broke the third time I got a new one which I sold immediately. Fair enough. What did you do with the old one? But yeah, I'm not a fan of these circuit layouts at all. They're not really designed with longevity in mind. Beast Boost, yep, I did. So basically, I'm getting the DATS V3. Owen is shooting his over, I think, or is it someone? Yeah, Owen is shooting one over to me. But I think I've got another one coming from a guy in the States who just wanted to send me his, like his old one or something like that. I'm not sure what it is, but basically, I think he's just happy for me to have it. So that's incredibly generous. So yeah, really, really cool. Okay, so there's probably a fair bit of heat in this PCB now. I'm not going to be removing this chip, I'm just going to be reflowing it. So I'm just going to heat it up until it's clear that all the solder has melted, and I can nudge it on its pads a little bit to show that it has actually melted the solder. And then we'll let it cool back down again and see if it magically comes to life. Well, there we go. It seems that we have already melted all the solder on it. I don't know if you could see there that it was it was moving a little bit on the pads. So let's wait for that to cool down, and then I'll clean the flux off it and power it up again and see if it comes to life. And if it does come to life, what I usually tend to do is stick a little heatsink onto the chip just to help it dissipate a little bit of heat while it's running. And that should prevent the heat cool cycles being quite so dramatic. Okay, so let's see if a quick reflow has done anything for this little lamp. So power back on, and we're going to check for Class D switching up at the inputs to this inductor here. See if it comes to life now. Hey, there we go. So we have Class D switching on that channel. Let's just check. Yeah, that channel as well. On that channel as well, probably. Yeah, that's the output of the inductor, and on that channel. Excellent. So yeah, all it needed was a quick reflow of the IRS2093M, which is seemingly the most common problem with these little amplifiers. So in order to try to help that not happen again quite so soon, and you can't ever completely prevent that from happening, because It's just the nature of this chip and how it's heating and cooling and the design. This is why I generally prefer through-hole components. Like, I prefer working on surface mount components because I find it just quicker. It's much quicker to just work on surface mount. But in terms of circuit longevity, through-hole is way better in my personal opinion. Like all the old amplifiers, all the old Rockford Fosgates and the stuff that just lasted years and years and years and years, everything was through-hole components. I feel like surface mount are just more susceptible to these kind of issues, poor solder connections and stuff, and also just the manufacturing process of the tiny surface mount like ceramic capacitors and resistors and stuff like that just tend to be more prone to failure over the years, I think. So yeah, what we're going to do is just grab a little bit of thermal pad, adhesive thermal pad. Lead-free solder is also probably one of a big reason for it. Yeah, lead-free solder is not the nicest stuff either. Can't you just put a little heatsink on it? Well, that's exactly what I just said I'm going to do. Little heatsink's going to go right there. I don't know how much it will help though, but it might help a little bit. But it's still going to have heat-cool cycles. Like, you can't get away from that fact. You know, it's still going to be like -2 degrees centigrade in the winter inside the car. And then when you use this amplifier, that chip is still going to get to like 40, 50, 60 degrees centigrade, even if it's got a little heatsink on it. So the heatsink will help a little bit, but I don't think it's going to prevent the issue. What happens if the heatsink falls off due to vibration? Well, yeah, that is a concern. But this adhesive tape is very, very strong, so I don't think we're going to have any issues with that. And there's also barely any weight to it either. So if the heatsink was quite heavy, then I'd be concerned, but the heatsink's aluminium, so it's very, very lightweight. So cool. So that was a nice easy one. Let's move on to something else. Sam, have you seen Northridge Fixes, his tools and techniques for repair SMD? I don't think I have really. I don't tend to spend a lot of time on YouTube watching repair videos, just because that's what I do on a daily basis anyway. I spend most of my time on YouTube watching AI videos. Oh man, if you're not following AI, freaking follow the AI developments in the last couple of weeks. The world is about to be a completely different place. I also watch a fair bit of aviation stuff. I'm not like mega into aviation or wanting to be a pilot or anything like that, but I don't know. It's just I like watching some aviation content. It's very technical, skilled work, isn't it? Piloting. So I like the complexity of the workload that a pilot has, and the decision making, and the troubleshooting as well when something doesn't go right. Kind of speaks to me a little bit. Opinion on Class T amplifiers. I think they aren't used enough. They were not the most reliable things in the world. Yeah, I'm not sure what caused it. Well, I mean, the TriPath stuff is all discontinued now. You can't get the modules, I don't think, unless someone has information I don't. But yeah, I think I don't think it was reliable enough. Cool. Right, next one. Should we have a look in this box? What is in this box? Is it a printer? No, it's not a printer. Yo, I did 22 years in the military as a hello pilot. I'll tell you, flying the aircraft is the last thing on your mind. Between navigation, communication, mission, flying the aircraft just kind of happens. I guess a bit like, you know, driving a car, riding a bicycle. Once you learn how to fly, that becomes second nature, and you're focused on the other, you know, the other tasks, which is the reason you're flying it in the first place. Yeah, it's quite fascinating. Yeah, technical specialists. It's interesting, isn't it, how people that have an interest in one thing, they might quite commonly share an interest in something completely different just because the minds work in the same kind of way. Yeah, what do I watch on YouTube? So I watch, I don't tend to watch repair videos because that's what I do, but yeah, aviation, AI. I kind of like watching video game glitches and out of bounds discoveries and stuff like that. Like, I mean, as a kid, I was super into the Pokemon franchise, the you know, the Game Boy original Gen 1 Pokemon games. So at times I'll spend lots of time. I'll spend time on YouTube watching like all of the ridiculous, crazy things people are doing with the Gen 1 game engine, and like, you know, people have written games while like in the Pokemon world using the character and pressing specific buttons. Like, you can write a game to the game's memory that then runs within the Pokemon game. It's pretty insane. So I'm just always into that because it's always crazy to see how far it's come since when I was a kid playing these games, and now you got people like writing games within the game, and it's just like, wow, all this stuff could have been done at the time. Like, imagine going to school and like showcasing some of these exploits and some of these glitches back then. Like, they were fully possible back then. It's like, whoa, dude. Okay, this is a piece of junk. This is an Edge branded amplifier. This is a brand we have in the UK. It's probably similar to the likes of, I don't know, Audio Bank or, I don't know, Audio Pipe or something. Or, I mean, Audio Pipe, some of the stuff's alright these days, but this thing is not a particularly well-built, well-designed amplifier by any stretch of the imagination. And they tend to have issues with the drive circuitry. So this amplifier is a Class AB, and it's asking a lot of power from the output devices, which isn't an issue in itself, but the issue is in the quality of the drive circuit components that they've used. Very poor quality drive circuit components, and I don't think there's enough of them, and they're run very hard, and they tend to fail very quickly. You could get mute, it just wasn't under the truck. That's right. However, someone modded the game, not with like a ROM hack or something. Someone actually was playing through the game and manipulating the game in such a way that they wrote the code to memory that Mew was under the truck. So you could actually go to the truck by the SSN, move it out the way with a boulder with strength, and then you'd encounter Mew as a battle. And you could, anyone can just do that. You could, if you want to manipulate the game in such a way to write that code, that data to the running, the memory of the game, then you can do that, and you can actually make Mew appear under the truck. Can you imagine doing that, man? That's cool. Jeez. Anyway, what's up with this then? So this is, oh no, hang on. This is a different model to the one I thought it was. I thought this was the 4-channel, because these are ones I usually see. This is the 1500.1. So this is a Class D, monoblock. Sorry. So let's have a quick look. This is the exact same circuit as, oh okay, this is an IR 2010S. Alright. Similar to the JBL GTO 14001 then in terms of drive circuitry. Do we have any output FETs? First of all, let's have a quick look. None on that side. So we've only got one output inductor, so that means we've probably got like low side over here and high side over here, for example. 285. Aha, there we go. There's one with the 15 ohms, so we've got one dead FET there. Okay, looks like we probably just lost one output FET. So if I go ahead and just snap that out for a second, and then we can power the amplifier up and see whether the drive circuit survived. So that should have removed the low resistance across the output FETs here. Yep, we're back in business. Wow, these output Mosfets have 100 ohm gate resistors. Huh? For output FETs? What FETs are they? Ah, IRFB 5615. I think these are incredibly low input capacitance, very low gate charge. So that's how they're maybe getting away with running such a ridiculously high gate resistor value on this. You only got 8 of them, so 8 of them for 1500 watts? Yeah, probably alright. Okay, so let's plug some power wires in then and see whether the drive circuit survived or not. Okay, Beric, can I have my coffee first? Yeah, man, smash it. Oh, here's a little thing that says details. Alright, let's have a look and see what it says. Amp is always in protect. You said it has blown outputs. I was right. My Facebook diagnosis was accurate. What's the time where you are? It is currently 2 PM in the afternoon. 2 PM. Damn, it's freaking early in the USA. Yeah, Beast Boost, odd header, content-wise, great. Enjoy the guy's content. I really struggle with his voice. I don't. His voice isn't the problem. It's the way that he records a voiceover for a video. I think perhaps he is unable to string multiple sentences together in one go. If you listen to an odd header video, it sounds like every 5 words are recorded by themselves separately, then spliced together. The voiceovers don't flow. I find it very jarring to listen to. I really struggle to listen to odd header videos, to watch odd header videos, just because of his way of recording and his voice on it. Did you fix that one from the other day with the blown power supply FETs? Did you find out why it blew? Was it shorted windings? Nope, the reason that the one from the other day with the power supply section failure blew was because the SG3525 dropped one of its PWM outputs, therefore only driving half of the power supply FETs, causing them to overload and fail. The transformers were fine, no shorts, no output section faults, nothing like that. Yeah, very strange one, very unusual for the 3525 to fail, but yeah, that's what it was. Alright, how's the drive circuit? You know what, I would probably place, oh it's tricky, I was going to say I would probably place a considerable amount of money on the fact the drive circuit is okay here, because we have 100 ohm gate resistors. If anything's going to be going funky with the output FETs, that high of a gate resistor value is probably going to dampen the blow significantly that the drive IC is going to survive. But the drive IC could have failed first, killing the FET. But I'm almost guaranteed that the output section, the drive circuit in this amplifier is absolutely fine. Let's have a look. See what we've got on the low side drain. The low side's over this side. So what are we saying? Do we have PWM or nah? Okay. It is trying to build PWM. I suspect this might be one of those amplifiers, especially with 100 ohm gates, that just needs a bit of kickstart from some signal. So if you've got really high gate resistor values like that, sometimes it can be tricky for the Class D self-oscillation to set up. So we're just going to give it a little bit of signal. Let's turn this gain. Gain was nice and low. Phase, boost, boost, boost. There's some pretty sensible settings on here, I have to say. The low pass filter was a bit high. So if we inject a little bit of signal, there we go. So yeah, just needs a little bit of signal to kickstart the PWM, and the drive circuit is A-OK, as I suspected. So we just need new output FETs. Now the output FETs that this is using, like I say, are a little bit unusual. I'll have to see if I've got any spares of those. If not, this is 1500 watts. I could probably get away with just replacing it with 640Ns with lower value gate resistors, because that's what most of these other amplifiers are using. But this is a, what is this? IRFB 5615. Alright, let's just Google that and just get a data sheet for a reference. IRFB 5615. What are we saying? Looks like I've looked at this relatively recently. So we are 150 volt FETs. Continuous drain current is about 35, so yeah, not massively powerful, but a fair bit more powerful than the 640Ns. But I think these are very easy to drive. So yeah, gate charge, typical 26. That is super, super low. And the input capacitance as well, 1750, very, very low as well. So that's how we're getting away with such high value gate resistors. Ridiculously low gate charge, nice low input capacitance. What's the switching frequency of this actually? Let's have a quick look. What's it actually switching at in terms of speed? Because obviously if it's too fast, that might be an issue. Oh, need the RCA signal back in to kickstart the oscillation. God, it needs a fair bit of signal to get going. Right, this is 72 kilohertz, so yeah, very low as well. Very low speed switching on the output side. So that's how we're getting away with 100 ohm gate resistors. So what to replace them with then? Let's see whether this data sheet has got one of those graphs that tells us the current versus the voltage. Okay, we're on junction temperature, on resistance, gate voltage, maximum avalanche energy, drain current, blah blah blah, thermal resistance, drain current, maximum drain current, case temperature, No, it doesn't really tell. Oh, here we go. Maximum safe operating area. Okay, so this MOSFET will produce the best results. It was saying it was a 35, I think it was 35 amp part with continuous current drain. With pulses, we are single pulse. Right, so this is only a single pulse graph, but it is operating at its best with the drain to source voltage lower than like, here we go, DC. So we've got DC. So with the drain source voltage lower than 10 volts, we're able to get our 10, 20, 30, roughly 35 amps. However, by the time we're up at the 100 volt mark, we are not capable of passing very much current. With a quick pulse of 100 nanoseconds here, or is it 100 microseconds, by the 100 volt mark we are at about 15 amps. So yeah, not probably the greatest parts, I would say, for this application. If we take a look at IRF 640Ns, how do they compare on that graph? Maximum safe operating area. So if we look at the rail voltage of this amplifier, which was, so we've got 12 volts going in. What are the rails? Plus minus 53. So we've got about 100 volts between the rails. So if we look at this graph here, 100 volts. With a 100 microsecond pulse, comparing it to the other graph, we're at about the same amount of current, about actually a little bit higher, 20 amps. So the 640Ns in this application, with running at a higher voltage, actually look like they might perform as good as, if not better, than these parts, which are labelled with a higher drain current than the 640Ns. But yeah. The 640Ns are better at maintaining that high current drain at a higher drain source voltage. So yeah, I think 640Ns are going to be absolutely fine to drop in here. But I'm going to lower the gate resistor value, I think, because that seems a bit high, 100 ohms. Most amplifiers use 10 ohms, but that's because they have an optocoupler in line, which massively reduces the strength of the signal drive. So I'll try 100 ohms in it first with the 640Ns and see what it does, but I might be tempted to drop it down. Let's have a look at the gate wave actually. So with 100 ohm gates, what does the gate waveform look like? So I'm going to probe the low side gate here, and we're going to have a look at the scope screen and AC couple the scope down to 5 volts divide. Let's see what this looks like. Right, so with these FETs, it actually looks pretty good. Like, I wouldn't have said, you know, if you'd asked me what's the gate resistor value on that, I wouldn't have said that was 100 ohms. That looks pretty clean, considering how high the gate resistor value is. So that's nice. Got good dampening from the high value gate, good protection against the drive circuit in a failure instance. So if we can keep a high value gate resistor in place, then that's beneficial for us here, because we've not got really any drastic issues turning the MOSFETs on and off here. Looks pretty good. 2 AM in NZ, nice. Something about Malaysia. I'm not able to read that, unfortunately. How's it going if you're tuning in from Malaysia? What's up? I'm trying to fix a PA amplifier. Active speaker, Opera 405D power supply. FET's blown, but still don't want to start up. Driven by an S213510. Changed. Also a 555 next to it, but don't want to blow my scope. Yeah, so probing the power supply section in mains amplifiers is tricky. So if you like IS6, what I do sometimes, which is a bit risky, make sure that you are well protected, wear rubber gloves possibly. The best thing to do is to obviously float the device under test. So if you do have an isolation transformer, use that. If you are in a pinch and you don't have an isolation transformer, you can lift the ground from your scope. So disconnect the scope's ground wire to the mains. This is dangerous. This is not advice. I'm not telling you to do this, but this is one method which can be used to use your oscilloscope to probe those power supply waveforms. And then you want to hook up your oscilloscope ground to whatever the power supply section is using as ground. It could be the neutral line, for example, coming in from the mains. That's one example. Or if it's using some kind of push-pull thing, you can hook it up to the other side of the push-pull so that there's actually like high voltage waveforms, PWM, on the ground of the scope, and it's looking at the potential difference between the two. The reason that's dangerous is because if you have that hooked up, if there is high voltage on the ground for the oscilloscope that it's using as a reference, if you touch the ground line on your probe, or if you touch part of the casing of your oscilloscope, you're likely to get a shock. So do it with caution, but you can do it if need be to read those waveforms in the power supply. Oh, if it's a battery powered scope, man, you're good to go. Yo, if it's a battery powered scope, it's already completely isolated, so you can literally hook up the ground probe on your battery powered scope to whatever you like. But I still wouldn't touch it, obviously, but yeah. If it's a battery powered scope, it is completely separate, and what it sees as ground can be it can have a high potential on it. It's just using that as a reference for ground. It doesn't have to be ground, it doesn't have to be 0 volts. It can be negative 200 volts, but if that's, and then the scope will use negative 200 volts as its reference for ground. So, yeah, let's see whether the rail voltage has dissipated enough for us to start working on this amp. Yes, it has. Okay, so although we only lost one output FET, I think it's probably going to be best we just replace all the output FETs. And if I'm honest, I'm probably just going to drop 640Ns in place. I don't think there's any need to try and fit these original FETs in because they don't seem very well suited to this application. Like, they don't produce much current up at the higher voltage that they're running at, so why use them, you know? Just out of interest though, I do want to see if I happen to have a spare one or two, just to see whether I've ever used these before. I feel like I have seen them before, but I don't really remember too well. What are they, 5640s or something? 5615, okay. So RFB 5615. Such a random Mosfet model to use in this amplifier. We've got RF 3415s, similar but not the same. Oh, there we go, there's a 5615. So I do have one. Because this is such a cheap amplifier, it's very tempting to just drop in one single Mosfet replacement. Even though the batches aren't matched or anything like that. It's very tempting to do that just because it's such a cheap piece of crap amplifier, this. But we're not going to do that. But I was just curious to see if I'd ever used these before. So yeah, that is that just out of interest, is it the same batch as what's used in this amp? See whether it's come from the same factory. BQ, P9, P0. Yeah, it's a very similar batch, so it might have even come from the same factory. But anyway, yeah, we're going to replace all of the output FETs for 640Ns, I think. And I'm going to drop the gate. Well, I'm going to try it with the 100 ohm gates in place, just to see how it runs. It's Friday. I'll drop one FET in. I could do, but it's not the right thing to do, is it? Did you get my 420 from the end of the last stream? I was trying to get Super Chat Loft Mish to go find donor parts for that second amp, but the stream finished and my bank confirmed the transaction. Oh, I don't think it came through. I didn't get the chat notification for it, but thanks very much, buddy. If it went through, then I guess it came through to me, possibly. I'll have to check my YouTube account, but yeah, thanks very much. I was trying to Super Chat Loft Mish to go find donor parts for the second amp. Oh, the Loft Mission. Loft Mission. Yeah, okay, cool. Yeah, no, I don't think it came through. I don't remember seeing it, but maybe it did come through, so thank you very much, buddy. It was a Loft Mission. It was a Loft Mission, and did find a 3525. I found one that I could test the amplifier with. It wasn't the correct package size. The original 3525 was quite a big one. And I only had a thin one. But I was able to use that just to test the amplifier and confirm that the chip was the culprit. So that's cool. What's up, guys? What's up? Alright, let's get the board out of this case. How's it going, Cron Limited? Amir says, I want to return on the format where the live chat fixes the amp. I feel like a high return on that content, to be honest. Yeah, that was a great live stream. I really thoroughly enjoyed the live stream where we got live chat to fix the amplifier. It was good fun. I was expecting the video that I made from that live stream to do a bit better than it did on YouTube. I was hoping it would be a pretty popular video, you know, get decent views and stuff, but it didn't actually do that well. So that kind of says to me that maybe the viewership weren't that interested. You know, people didn't really like it that much. But it could just be an algorithm thing. It's just not serving it to many people. But yeah, I thought that that video and stream would do better than it did. Oh, it is 6. Thanks for the 420 again, my man. Yeah, next loft. It's always a loft mission, man. It's always a loft mission. Just building a 3.2 kilowatt RF amplifier. Bloody hell. Good job, man. Is there any more screws in this? Oh yeah, there's a couple more screws. Couple more screws. One there. And one down there. Awesome. Here is a viral video. ChatGPT fixes car app. Yeah, I've been tempted to do that. The only problem is, I don't know if ChatGPT would have, because I'd basically have to try and, it would work with ChatGPT 4. Okay, if I had access to ChatGPT 4, I could upload a schematic to ChatGPT 4 of the amplifier that I'm working on. I could say, this is what the amplifier is currently doing, how do we fix it? That would be great. It would probably smash it. But with ChatGPT 3, I'd have to give it so much text-based information on the layout of the amplifier and the parts in the circuitry. It might be quite tricky. What I do want to do though, is I do actually want to get ChatGPT, either 3 or 4, to design an enclosure for Boom or Bust. I'm going to give the AI all the specifications, TS parameters, dimensions, and the brief, and see what kind of enclosure it comes up with. Right, surely that's got to be all the screws. No, it still feels solid. What have I missed? Have I missed a screw somewhere? Da, 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 da. I don't think so. No, definitely feels like it's screwed in still. Right, there's one there. Got that one. One there, got that one. Got the two from the end plate here. 1, 2, 3, 4, 5, 6 off of this end plate. Ah, I think there might be one here, hidden by this glue. Yeah, just looks like a glue dollop. Oh man, it still doesn't want to come out. Oh, there's another one hidden by a glue dollop. There's loads of screws in this board. Okay, so yeah, let's just get all these output FETs off the board and then replace them with the 640Ns, and then we're going to find out whether the 100 ohm gate resistors are too high for the 640Ns. I think they're probably going to be alright. You know, I think we're probably going to be fine. Seems there's a fair bit more thermal mass in these boards than I anticipated. Let's get the big air soldering iron out, just to make life a bit quicker. Yo! Wait for that to heat up. It takes a while to heat up this one. Should we have a look and see what ChatGPT 3 would come up with for boom or bust so far? Just while my soldering iron's heating up. So let's just quickly log in with this. Okay, let's have a look then at what ChatGPT would think to design for boom or bust. So the prompt is very, very important with this to get it to output the correct format. So basically, okay, I'm going to tell it, you are going to design a, I don't want to tell it subwoofer enclosure. No, actually, do I tell it to design one for low frequencies, like, and then scale it down for boom or bust, or do I tell it to design one with the boom or bust frequencies in mind? It might be easier to just tell it to design a full scale one and then we scale it down. Subwoofer enclosure as part of a contest. I will list out you will output you output the dimensions for the enclosure including external and any internal structures. Yeah, what's the best way for me to get this, to get ChatGPT to output this as, like, I can tell it to just tell me the dimensions, but then I've got to interpret that into some easy way to then model it up. Can I get, I mean, I know it can't draw. I think ChatGPT 4 can provide pictures, can't it? But I can't get it to draw, so... ChatGPT can output G code. Are you serious? No! Can it really? Alright, fine. Okay. In that case, we're going to change our prompt a little bit. Speaker enclosure as part of a contest. I'll list the parameters to be taken into account. You will output G code. G code. Okay. To give it the TS parameters. Is this going to work? Is this actually going to work? All right. Let's get the TS parameters up real quick. Docs.google.com. Okay, I'm just getting the TS parameters for the driver, which are here. So let's copy those. These are in Clio format. The enclosure needs to, the winner of the winning enclosure will have each enclosure will be tested for dB level at 4 different frequencies: 150 Hz, 198 Hz, 270 Hz, and 360 Hz. The winning enclosure will have the highest average dB score across these 4 frequencies. Your design may take the form of any style you like, with ported, bandpass, quarter wave designs such as horns, etc. Okay. The maximum dimensions for the enclosure are, what were the maximum dimensions? Here we go. These are purely limits, and the box doesn't have to be this big, but must fit into this space. TS parameters of the driver are as follows. The desired parameters for 3D printing to implement into your G code are as follows. Nozzle diameter 0.6 millimeters. Number of walls 3. Number of top bottom 3 as well. Let's go for print temp to 30C. What other things do we need to tell it? Build plate temp 65C. What other things do we need to tell it? We need to tell it that we want layer height 0.42 millimeters. Print speed 32 millimeters per second. Let's just leave it at that for now. We could do all the travel speeds differently. What other important print parameters do I need to tell it? We've got the nozzle diameter, layer height, maybe the the width of the wall, number of walls 3, wall width. It should assume that anyway, but be pretty nuts if this works, eh? I don't know if it will work, but we can see. Layer height 0.42 millimeters. The enclosure will utilize one single 2-inch speaker. A single 2-inch speaker. I think that's everything it needs to know. Can anyone think of anything else it might need to know? Specific printer settings like nozzle offset and such. I'm hoping that it will. I'm hoping that it will get that information from other sources that it's got in its database about the Ender 5, because it's been trained on the internet before 2021, so it should have some information about the Ender 5 Plus. Alright, maybe shall I just hit go and see what it does? I think I've told it everything. I've told it the dimensions of the cabin. Oh, I can also tell it what the cabin has. The enclosure will be placed into a test chamber, which itself has a helm hole mode at 145 Hertz and a quarter wave resonance of 190. I think it's 180 Hertz. Alright, that's all it. And taking a dB image, which itself has a helm. Right, let's just see what it says with that information. Internal volume enclosure. It's going to tell us how to do it, not to actually. It's not going to give us the G code, I don't think. Wait, is that within my specifications? 135 by 195 by 220. No, it's bigger than. Oh no! Oh no! It's not. It's not. It is within. It is within spec. Okay. We use a rectangular box shape with rounded edges to minimise diffraction of the edges. The enclosure will be made of high quality plywood. No, it won't. It's going to be 3D printed, you dingus. Okay, I guess it's writing the G code now, so this might take a while because it's going to be some pretty hefty G code, I reckon. Okay, it's not. I need to get it to continue it, don't I? This G code will create an enclosure specified dimensions parameters ready for tested. Shall I ask it to continue generating the code? When I have it write out scripts in PowerShell or Python, I generally have had the best luck in building them up with my requirements across multiple entries. Yeah, that makes sense, because you have to just kind of... Yeah, because it outputs different results every time, right? So once it's done this, what we'll do is I can import that G code into Cura, which will then visualize what it output. Be very interesting to see. Right. In the meantime, let's remove these FETs. Oh no, wait, it wasn't even... Oh my gosh, it wasn't even getting hot because it wasn't even turned on. No! Oh man, alright, fine. Give it another minute then. Is it still going? Doesn't look like much. Does it start again? I'm probably going to just bunch all of this code together, print the interior supports, print the top and bottom layers, print the walls. I've seen this video where someone asked it to 3D print a description of its existence, and it generated some weird sphere looking thing. Man, that's freaking interesting. Yes, so Brian, yeah, you need to bypass the resistors that are in line with the 15 volt supply, 15 volt plus minus supply. Perhaps the code is only limited in the window. I'll try it. I'll try it. It sort of gets to a point and then it stops. Like if you look here, it gets to a point and then just kind of stops. So let's try copying this code for here. Let's bang it into Notepad. I mean, I'm just curious to see. GPT box 1, and then let's do this one. Okay. So yeah, I get the feeling this isn't going to work because I don't think it can spit out enough code. Although people have got ChatGPT to write apps for them and stuff, haven't they? So how does that work? Right, let's see what it looks like in Cura then. Okay, so this is the first one. It seems to only be this. This is the first one that it's done. one layer, and it's literally just this. Okay, let's try another one. And that just doesn't seem to be much either. So yeah, it seems that that doesn't really work. Yeah, not very useful, Chat GPT. Sorry about that, buddy, but not very useful. Maybe if I can get access to Chat GPT-4, we can get it to output a picture of what it thinks the box should look like. Maybe instead of getting it to write G-code, I could just ask it for some dimensions. Or maybe I could just ask it for the specifications of the box. Like I could say, you know, what should the internal volume be? Should it be a transmission line? Should it be a horn? Should it be a band pass? Do you want to know one crazy thing though? Obviously with plugins now, so there are now plugins available for ChatGPT or GPT-4. So if you installed a plugin that was horn response, for example, or WinISD, then it could actually use those programs to formulate like the ideal enclosure. That would be pretty insane, wouldn't it? Maybe have it output an STL file. I don't know, how could it output an STL file? Could it do that? Okay, let's just see whether it can do an STL file instead then. So if I go to back, I'm gonna start a new chat with it. Rather than, so I'm just gonna copy this original prompt. New chat. Get rid of the 3D printing stuff. can't do STL files. How can we get it to output something that we can turn into a 3D model? Please provide all dimensions to model this. Model your enclosure. Seems like it's doing a bit more work this time. Wait, what? Dimensions will be 150mm by 210mm by 21.7mm. Have an internal volume of 0.2 litres. Right, okay, hang on a minute. But it hasn't okay. Can you give me the details of the enclosure you designed? A sealed enclosure. Oh, it just wants a sealed box. But surely that can't be right. So it wants 150 by 210 by 21.7. So it wants what does it want? It wants width as 210, 21.7. 210. And then the height, it wanted 150mm. Right, so that, ladies and gents, is the sealed box that ChatGPT thinks will win Boom or Bust. If we do 3mm walls, the driver's not even going to fit in this, is it? Yep, the driver is not going to fit in that unless the driver is invert mounted. Ah, clever. Let's invert mount the driver. Then it will fit. Midpoint. Midpoint. Oh, come on, lock into this freaking midpoint. Midpoint, yes. Midpoint, yes. I can't actually remember what the cutout diameter was, but let's just go for shit. $25. Right, there we go. That is the ChatGPT sealed box that's going to win Boom or Bust. Invert mounted on that, and that's going to be our winning box, apparently. What a box. I could ask it some questions about its output. I could ask it, are you sure that a sealed box is going to have the loudest output across these 4 frequencies for this competition? I feel like we need ChatGPT 4 for this. I feel like if we're going to do this, if we're going to do ChatGPT designs and enclosure for Boom or Bust, it needs to have, it needs to be able to look at pictures, or it needs to be able to output some kind of pictures or G-code properly, or some kind of file, and it also probably needs access to WinISD, which it can have through plugins. So perhaps that's going to be a project for us if I can get access to ChatGPT 4. I don't think it's assuming the walls are going to act like a passive radiator, because it hasn't told me the thickness of the walls or what material they're made out of. I don't think it might have said plywood, but I don't think that it's going to have taken that into account. Right, let's ask it to follow up on its suggestions here. This competition is for loudest DV SPL. You sure that the sealed box you So now it wants a very similar sized box, 210 by 23.3 by 150, and the port is 25mm in diameter. That's freaking massive. A length of 43.2mm. How's it going to fit? How's the port going to fit? It doesn't fit. A port with the 25mm diameter does not fit into that box. Have a look at your... Can you see how a 25mm diameter port cannot... No, it doesn't have a freaking clue. It does not have a clue. What's good, Sine Wave? How's it going, buddy? Okay, that's one side in. Let's get the other side in. I feel like it's taking into account multi-dimensional sub-enclosure design. Our feeble 3 dimensions are not enough to, so it's building a Penrose sub-enclosure. Fair enough. Why do the circuit boards on my TV say they're magic? Right. Almost done with this amp, and then we'll be able to find out whether 640Ns are going to be compatible here. What's up, Justin? How's it going, buddy? Thanks for jumping on. Should we get it to write some random G code of something that would make me laugh? Let's have a look. See whether it will do that. Oh, come on, that's not what I meant. It's just creating a cube. Write some G code for write some G code for a small So this is what it thought a smiley face would look like. It's one layer, and it's that. So I don't think that ChatGPT is very good at making a smiley face. This code will draw a simple smiley face in the shape of a circle with 2 dots for eyes and a curved line for the smile. Well, that's definitely not what it's going to do, is it? Okay, let's have a look and see whether this is going to work now. 12 volts going in. I want to see whether there is good low side drive on the gates, because we have 100 ohm gate resistors in line with these FETs. So let's just check that it comes on first of all with 640Ns in place. And it will need a bit of a kick start because the gate resistors are so high. There we go. Looks good. Okay, and how about the gate drive? Gate drive looks good to me. Yeah, those 100 ohms are doing just fine. No need to replace those out. So it's good to go. Good evening, Hossam. How's it going, buddy? Hope you're well. Put some fresh thermal paste on these. There we go. Yeah, these clips are pretty tough. These aren't the hardest clips I've ever had to deal with. They're pretty lightweight on these ones. Some of the newer Korean ones are very, very tough to get off. Bevis, can you summarise what the repair of this one was? And yeah, I'll summarise this repair in a second. I'm getting a bit of a sore throat actually, guys. Sorry I'm not talking too much just now while I'm doing this. The throat's starting to go a bit sore. I don't know if that's just because I've been streaming quite a lot recently and talking quite a lot, or whether I'm coming down with something, but it feels a bit tender in there, so I'm just going to take it easy for a minute. Okay, one last power up to make sure that it's still good now it's back in the case. A little bit of RCA signal going in. There we go, there's a nice clean signal on the output. Excelente. 14.5, all good as well. Cool. So this amplifier came in with dead output Mosfets. The output Mosfet, it had one dead output Mosfet. The output Mosfet was an IRFB 5615. Not too used to seeing these used, so I had a look at the data sheet. Turns out that they are supposedly more powerful than the average RF640N that's used in this style of amplifier. However, when you actually look at the graph which dictates how much current the Mosfet can produce at different voltages, drain source voltages, was actually weaker than the RF640N at the kind of voltages that this amplifier is used around. So therefore the RF640 is actually a better choice for this amplifier, so that's what I have fitted it with. Okay, now I can go back in the box. Now let's have a look at what we're going to be repairing next, shall we? Let's have a drink. Okay, what do we have? What is this? Should we have a look at this? Not very well packaged, this one. So there's no padding in the end there really. Well, there's this little bit here, but it doesn't seem to really be actually on the amp. This is going to be a JBL GTO 14001. Very nice amplifier when it works, which most of the time it does. They're not that unreliable. These are pretty good reliable amplifiers. For for some reason this one's made its way into the workshop, so we're going to find out why. Okay, so looks like we've got some burn marks over by the power supply FETs, but let's see if that's current or whether that's something that happened a while ago. Looks like it might be current. Yeah, so dead power supply FETs. A little bit uncommon in these, but okay, let's move on and see why we've got dead power supply FETs. Are the outputs toasted as well? So that's one half of the bridge. This is a full bridge amplifier, so these 4 FETs are one channel. And these other 4 FETs are the other channel, so the output FETs are not shorted. Okay. Let's have a look at the transformers. The transformers aren't seated down brilliantly. They're not bad, but they're not that great either. So that could be one reason why the power supply FETs have died, if the transformer's bad. But let's remove all these and find out why the power supply FETs died on their own. IO3205s, all toasted. There's quite a lot of screws holding these boards down, which is quite good to see. Should prevent vibration damage. That should be all of them. Well, I usually forget one. Oh no, that is all of them. Yep, cool. Let's get these little ceramic plates to stay in the main case. Yep. Okay, cool. So it starts off by cutting out the 3 remaining FETs on this bank here that seems to fail. So we've got 4 FETs on this bank pushing the transformer and 4 FETs on the other bank pulling the transformer. So let's remove those. Check to see whether the other ones are dead as well on this bank, or whether it was just one bank that failed. Okay, no, it's all, both banks have failed. Okay, cool. That's usual, it's pretty standard. Okay. Let's start removing these from the board. Common problem on the Sound Digital, really it's just output FETs seem to die randomly for no reason. I think it's because the output FETs are ran so close to their voltage limits. I think that, like, for example, 1200 D1. So that's not the 12K, that's the 1200 D1. Let's have a quick look. I don't see a 1200 D1. Do you mean the 12K? Laurie, do you mean you bought the 12K version? Are you missing a 0 from that? Yeah. If it's the 12K, the output FETs are just ran very close to their voltage limits, and so they tend to spontaneously short sometimes. $1.2K. Oh, okay. I couldn't seem to find that one on the internet, but yeah, I mean, not really. There's not really any common problems that I'm aware of with that model, so you should be good to go. Also, just going back to ChatGPT real quick, I told it that the port wouldn't fit in the box that it specified. So it changed one of the dimensions of the box, but didn't change the internal volume. So it clearly has no idea what it's doing about that. Pull down resistors don't save the transistors, buddy. Unfortunately, that's not how it works. Nothing is really going to save the transistors other than running them further away from their voltage breakdown limits. That's pretty much it. Hey Mark, thanks for the 10, man. I really appreciate that. Thanks for sharing knowledge. Anytime, literally. Any questions anyone wants to know, I'll happily share whatever insight I have. How about using a different transistor with better voltage handling? Yep, possibly, but you might not be able to find transistors that have a high enough voltage handling, but that also can sink enough current for the amplifier. So obviously as the voltage handling goes up, the current handling usually goes down. So if you can find a higher voltage rated transistor, Mosfet, that can pass the required amount of current that the original could, then that will be much better, yeah, definitely. Now, hopefully the drive transistors are okay on this amplifier, because they're a little bit of a pain to get to. If you have to replace the drivers on these, they're a little bit tricky to get to, but it can be done. It's just fine. It's no issue if they are dead, but it's it'll just be a little bit more annoying. That's all. How big change to receive tare amps with holes in the caps? Do you mean chance? What's the chance of receiving a tare amps with holes in the caps? I don't know. I haven't had that issue for a long time. I had that issue with Banda way back at the start when we were importing them. They drilled holes straight through the heatsink, the entire case of the amplifier. Yeah, I'm not being aware of that recently. Alright guys, I'm going to head off the stream now, I think. I'm just not really feeling it today. I'll catch you another day at some point. Yeah, cheers for joining me today, and I'll